Imagine sitting at a restaurant. There's no waiter around, and yet you open the menu, place your order, and even pay, all thanks to a black and white square that looks like something out of a 1990s printer. Yes, we're talking about the QR code, but how does it actually work? How can such a simple-looking image carry so much information? And why is it suddenly everywhere? From food packaging and business cards to museum signs and even gravestones. QR stands for Quick Response. The technology was first introduced in 1994 by the Japanese company Denso Wave, a subsidiary of Toyota, which developed it to track auto parts during manufacturing. Unlike the traditional barcode, which stores data in only one direction, horizontally, a QR code works in 2 dimensions. This allows it to store a much larger amount of information in a smaller space. When you look at a QR code, you see a square made up of smaller black and white modules. These tiny blocks represent binary data, ones and zeros, encoded into a pattern following a very specific standard. A QR code can store various types of information: plain text, URLs, phone numbers, payment details, or even login credentials for Wi-Fi networks. In the top left, top right, and bottom left corners of every QR code, you'll find 3 distinctive positioning markers. These bold squares help scanners, whether it's your phone camera or a dedicated reader, to quickly detect the orientation of the code. Thanks to them, the device knows where the code begins and ends, even if it's tilted, skewed, or partially covered. The 4th corner typically holds an alignment pattern to further refine the reading process. The central portion of the QR code contains the actual data, distributed according to mathematical algorithms and wrapped in something called error correction. This is based on what's known as Reed-Solomon codes, which allow the QR code to remain readable even when partially damaged, whether smudged, torn, or obscured. In practice, this means that up to 30% of the QR code can be missing, and it can still be scanned successfully. When your phone or scanner reads a QR code, the software first identifies the positioning markers, maps the matrix, and decodes the binary values. These are then converted into readable content, like a website URL or a string of text. The entire process takes less than a second. What's truly fascinating is that a QR code contains no chip, no battery, and no electronics of any kind. It's a purely passive object that transmits data visually. You can print it on paper, display it on a screen, stitch it onto fabric, or even engrave it into metal. And it will still work, as long as there's contrast and the pattern is intact. That independence from digital infrastructure makes it one of the most robust and versatile tools in modern communication. But QR codes aren't just simple carriers of data. With dynamic QR codes, the link can point to a server that updates the content without changing the physical code. That means you can print a poster today and change the target destination next week. It's a powerful tool for marketing, logistics, and anything that requires flexibility. There are even encrypted QR codes designed to carry secure or private data with built-in authentication. The COVID-19 pandemic brought QR codes back into the spotlight. Suddenly, they were everywhere, used for contactless menus, vaccine records, restaurant check-ins, and mobile payments. Their popularity soared because they're cheap to produce, easy to implement, and compatible with virtually every smartphone camera made in the last decade. All you need is contrast, structure, and a scanner. Interestingly, there are 4 levels of error correction: L, M, Q, and H, with H being the highest, allowing a QR code to still function even if 40% of its data is corrupted or missing. That's why companies can safely insert logos, stylized graphics, or color gradients without breaking the code. Behind the scenes, error correction kicks in, reconstructing the lost portions in real time. Despite how basic it may look, the QR code follows rigorous technical standards, most notably ISO IEC 18004. This international specification defines everything from the code's layout and encoding formats to how readers must interpret damaged patterns and verify data accuracy. There are also micro QR codes designed for tiny packaging and secure QR codes, SQRC, which restrict access to specific layers of information. More recently, we've seen frame QR codes, which leave a space for embedded images or brand elements. Some even integrate with augmented reality. Scan a code and a 3D object pops up on your screen. In other words, the humble QR code has evolved. It's no longer just a square of pixels linking to a website. It's become a bridge between the physical and digital worlds, one that's open, standardized, and incredibly powerful. So next time you see that little black and white square on a flyer, a package, or a screen, don't overlook it, behind its static appearance is a living system of math, design, and technology that connects us all faster than we can blink. Subscribe us for more videos.